All right. So I'm doing a little bit different technique, gentlemen. So like if you're on the Zoom call, I can't hear your audio. I have a hardwired line going directly into my iPad. So if you like unmute yourself, I won't be able to hear you. So you just have to. I'll just try to check the chat. Come on. I'll just try to check the chat, but you have to use the chat to get my attention, and I'll just try to kind of pop back and forth. Yeah, I need another because I wanted to have a wired line, and I do have a wired microphone, but then if I use the port, I can't hear anything. So yeah, just use the chat, and I'll just try to check the chat periodically. If you're just joining us, you did make it into my attendance. And let me do a quick recap of my announcement. So originally, I was not going to stream. Let me pull it up right here just to make sure my audio is working. Originally, I was not going to stream. Give me just a moment. Play. That's fine. Yeah, let's do it like this. Disconnect. Originally, I was okay. Yeah, so the audio is fine. Originally, I was not going to stream, but then I thought I had an extra day, but we actually lost a day. So the last day of class, I'm under the impression that the last day of class is next Wednesday. So we have today's session, we have Friday, and we have next Wednesday, but we lose next Friday. So because we lose next Friday, originally today I was going to work on section 9.5, but then since we lose a day, I'm going to rely on my recording. So for section 9.5, that's on the binomial theorem. I went on and did that lecture. I did do the lecture last Friday, but it didn't dawn on me until about 2 p.m. that it was a holiday. So I let the recording stand. You should be able to access it. I need to make sure I updated that thing. But it is there. It's on my channel. So you can see the recording for section 9.5 on the binomial theorem. And what we're going to be doing today, we're going to start reviewing for the final. We're going to basically take each day to review. Let me share my screen so you guys can see it like this. So we're going to take each day to review an exam. So I think we had a total of 3 exams. So today we'll go ahead and start with exam 1 and try to make our way through as many of those questions as we can, okay? So basically what we're doing, we're taking the exam, so we don't really know if it's right until we submit it, right? So, we're just do the best we can with the time and we'll see how we do, which means that we can get some wrong, but it should be minimal. So the graph of the function f is given. We're actually use the horizontal line test to determine whether it is 1-to-1, right? So 1-to-1 means that, so a function being 1-to-1 is synonymous with it having an inverse, right? So the whole inverse function discussion. Inverse function is essentially going to undo a function. Like if you have an input and pass it through your function, and then you get an output, if you take that output and pass it through the inverse function, is basically going to take you back to where you started, right? So with a graph, to test whether a function is 1-to-1, it basically needs to pass the horizontal line test, right? So 1-to-1 is the horizontal line test. So with this one, notice no matter where you draw a horizontal line, it touches the graph once. So that means it passes the horizontal line test. So that means yes, it's 1-to-1. So we're going to go with yes there. Again, we can't see the score until we submit. Let me see. So given this f and g, what is g compose f and f compose g, right? So this is composition of functions. This is one function inside another. I'm tempted to skip it, but I think I'm gonna just go ahead and do it fairly quickly and just try to be a little bit quick with it because we don't have a lot of time. So let me take this. I'll take it about here. And we're just gonna take this guy and drop it. Come on, right here. Boom. Okay. All right. So hopefully my pen should have enough. Let me see what it's fine. So we have this f and we have this g. So then g composes f. Let's start there, right? So for the first part, we're asked, what is g compose f, right, of x? So this open circle, just to kind of jog your memory, oftentimes the common error that students do with this symbol is they think it's multiplication. This is not multiplication. This means the second function inside the first function, right? This is called composition of functions, right? So what this means, we have G compose f of x. What this means is G of fuchsia. I'm going to do this color for f. G of f of x, right? That's what it means. The second function inside the first function. Okay, so if we take the second function, what is our f of x? Is -1 over x. What we're going to do is basically rewrite g of x. Well, we're going to replace all the x's in g of x with the fuchsia color. That's the closest that's the best I can do as far as what I think fuchsia looks like, right? So basically, we're going to rewrite g like normal, but we're going to replace each x with the pink or fuchsia color, all right? And then we're going to simplify. So then double negative becomes positive. When you divide by a fraction, you multiply by the reciprocal. This one boils down to just x. And I want to say if you do, in this case, it just happened to be the case where if you G compose F just happens to be equal to F compose G because they're the same. And it just happens to work out that we get the same thing, right? I'm just not going to do it just for the sake of time, but you should be able to make that connection. So with that, let's hop back over here. What is G compose F? Okay, we're going to put X. And then F compose G should be the same thing. Are they inverses, right? So to verify that two functions are inverses of each other, when you say F compose G, you should get X. When you say G compose F, you should also get X. So as long as both of those, F compose G and G compose F, as long as both of those equal X, then we could say that, yes, these functions are inverses of each other, okay? Let me just check the Zoom really quickly. That's not Zoom. I think the chat looks okay. Okay, let's keep going. Okay, so we're going to go with that and go into the next question. I'm watching the clock. We're pretty much about halfway. We're asked to graph the inverse of the one-to-one function f, right? So f is in blue. So now, given a graph, to graph is inverse, like one to me, I feel like a more simple technique, like if you had a list of ordered pairs, like a table of points that's on your graph, your x comma y, if you've confirmed that the function has an inverse, you can just switch those two columns. So x becomes the y and y becomes the x, and then plot those points. That's the simplest way, in my opinion. In a graphical sense, if you basically what you want to do is rotate your original graph. It takes a little bit of like imagination, but you want to rotate the original graph along the diagonal line y equals x, right? So it's like it rotates in a 3D sense. But if you take your original graph and rotate about the line y equals x, that'll be the graph of your inverse. So the one of these that's rotated about the line y equals x, I think is B. Wait a minute. It's not B. It's C, right? So again, what you could do is find a set of ordered pairs and then switch the x and the y's and then plot those points. That'll be the graph of your inverse. Or you, using your imagination, you have to rotate about the diagonal y equals x. But I think the only one that really does that is C. So I'm just going to go with that and go on to the next one. Not worry about it. Find the inverse of this function and then give the domain and range of f and f inverse, okay? So they give us that this function is one-to-one, and we're asked to find the inverse. So to find the inverse algebraically, you essentially just switch the x and the y. So you write y equals this, whatever your function is, and then you switch the x and the y's, and then you solve for y, right? So let's get a copy. We're going to take it from here to about here. And I'm bypassing that stuff down there for now. I'm going to take that and drop it right here. Okay. All right, so let's work here and see what we can do. Okay, so find the inverse, right? So let's start with the original. So we have f of x equals, we got this x plus 8 over x minus 7, right? So now to find the inverse, there is this whole procedure for verifying that it's inverse. I'm just not going to do it right this second. But the first thing we want to do is replace f of x with y, all right? And then we get this. Everything else just stays the same. Then what we want to do is basically switch our x and our y's. So if you see a y, write it as x. If you see an x, write it as y. So then we're going to have x equals y. X equals y plus 8 divided by y minus 7, right? So then we want to try to solve for y from here. So what I'm going to do to solve for y, I'm going to multiply both sides by this y minus 7. Right? And on the left, we're going to have to distribute. On the right, they're going to cancel each other out. Okay? So on the left, we're going to get x times y minus 7x equals y plus 8. Now, if I'm trying to solve for y, any term that has y, I'm going to get it on the left. Any term that has x, I'm going to move it to the right. So we're going to do this by subtracting y on both sides and adding the 7x on both sides. Okay. And again, if anything is not clear, feel free to type in the chat. I can't hear you if you unmute yourself because I'm using, just because of the headphones that I'm using. I have a wired microphone, so I wanted to try it out over my AirPods. The AirPods were, the battery was always dying. The sound kept coming in and out. So I'm trying a different technique to see if I can get a better audio, a wired technique. Let's see. So these guys cancel each other. These cancel. On the left, we're left with x times y minus y. On the right, we're left with 7x plus 8. Now on the left, what we want to do is factor out the y. Okay. Then that'll give us y times x minus 1. And then on the right, we have this 7x plus 8. And then the final step, divide both sides by x minus 1. Okay. So then we get y equals 7x plus 8 over x minus 1. So then this is our f inverse. 7x plus 8 over x minus 1. If we wanted to verify, well, we kind of talked about that. To verify this, if you do f of f inverse, you should get x. And then when you do f inverse of f, you should also get x. We got 7x plus 8 over x minus 1. 7x plus 8. 7x, let's do like this. 7x plus 8 over x minus 1. Okay. Okay. The domain of f. Okay, let's hop back over here. So we want the domain of f. So with a function like this, the domain of something of this form is going to be all reals except any x that makes the denominator 0, right? We cannot divide by 0. So what that means is that we have to throw out x equals to 7 because x equal to 7 is going to make a 0 in the denominator, right? So the domain of this guy is going to be everything except 7. Everything except 7. So then if to capture everything except 7, the domain of f, everything except 7 is C. Okay. So then let me see the range. Okay, so let's go ahead and let's do the domain of f inverse. Suppose we're just gonna, trust that our work is good. So if we want the domain of f inverse, it's the same principle, right? Everything except any x that makes the denominator 0. So we have to throw out x equals to 1. Okay. So x can be everything except 1 there, right here, D, right? So now we've identified the domain of f. We've also identified the domain of f inverse. So then one nifty thing is the domain of f is the range of f inverse, and the domain of f inverse is the range of f, right? So they kind of go hand in hand in that sense. So the range of f should be the domain of f inverse, which is everything except 1 right here. Also, what you can look at, so if we go back to f, well, no. We're talking about all the possible y values. So this one would have what? A horizontal asymptote, right? So we would ask ourselves, does it have a horizontal asymptote? So this is a good chance to kind of recap horizontal asymptotes. So there's a three-pronged test for horizontal asymptotes. When you have a rational function, you're looking at the degree of the numerator versus the degree of the denominator. In this case, the degree of the numerator is the same as the degree of the denominator, right? So when the degree of the numerator is the same as the degree of the denominator, then your horizontal asymptote is going to be the ratio of your leading coefficients. So it's going to be 1 divided by 1. So that's why. So we have a horizontal asymptote at y equals 1. And this never crosses that. So the range in this case is everything except 1. So I just use a horizontal asymptote there, or I just use the domain of f inverse. So then the range of f inverse is going to be the domain of f, which is everything except 7. Okay, so this guy. Let me check Zoom, the chat. The chat looks okay. All right, we're gonna go into the next question. So we got to review, finding the inverse. We talked a little bit about horizontal asymptotes and that three-pronged test. Yeah. So my recommendation with these reviews, just write down the topics, get whatever you can from our experience, but then you want to go back and refresh yourself on just look up and work a few problem sets from covering those different topics. So remember, exam 1, and it just came from the first stuff. So if you go back to Pearson, you can see like everything matches up. And then also, hopefully you've been taking notes, because this stuff is going to lock out, right? So if you have like a hard copy notes, like something on paper, and you've been organized, you'll have access to it during the final. But if you haven't, this stuff, or even if you did it digitally, you can print it and save it, but just make a digital copy of it, so that way you can use it. Because again, everything will lock out that May 1st. So if you don't have a copy of it, then you can't use it. All right. Okay. We'll go for about another 5 minutes. So this function, they give us that this function is 1-to-1. We're asked to find the inverse and domain and find the range of f using f inverse, right? So once you find the domain of f inverse, then that gives you the range of f. That's another way to do it. Let's just go ahead and knock this one out. I don't think it'll take us that long. It might eat up our time, but let's just go ahead and knock it out. So I'm going to pull it from like here. There's pretty good. And then here. And here. Okay. And let's make it a little bit larger. The funny thing is, on my TV right now, I could click on this presentation, and even though I'm working here, I could see the final product of the on the TV. Okay. But I'm not doing it because I feel like it'll be distracting. Well, actually the audio is down, so I am going to pull it up just to see, just because I can. For more options. I don't want more options. I just want the audio down. Yeah, it's working. Wow, that's cool. Oh man, listen to that voice. Who's this guy? Okay, anyway. All right. So let's go ahead and find the inverse. So we're given that it's 1-to-1, right? So let's just do that process a little bit faster. So for part A, we're going to have y equals 8x plus 2 over x plus 2, right? We switch our x and our y, so now we're going to get x equals 8y plus 2 over y plus 2. And then we solve for y. So I'm going to multiply both sides by y plus 2. I'm going to get xy plus 2x equals 8y plus 2. I'm going to use algebra to get any term that has y on the left and any term that does not have y on the right. So I'm going to subtract, the xy is going to stay. Subtract 8y is going to give me this. Subtract the 2x is going to give me negative 2x plus 2. Okay. On the left, I can factor out a y. So if I factor out y, I get x minus 8. I'm just going to rewrite the right-hand side as 2 minus 2x. So then ultimately, f inverse is going to be 2 minus 2x divided by x minus 8. Nope, undo. Okay. I'm just going to go with this. I know we're almost short on time. Yeah. So this will probably be the last one. Maybe what I'll do with my later class, I'll just try to pick up where I left off. And then you can use both presentations together to get more information as opposed to going over the same thing. 2 minus 2x divided by x minus 8. Let's see if I can type. That would be nice if it works. We got, let's hit fraction. Okay, that's looking good. 2 minus 2x. That's okay. Two minus 2x divided by x minus, it's not going to work there. Let's do this. 1, 2, 3, 4. Let me see. Oh, yeah, there it is. I knew it was something. Okay. 2 minus 2x divided by x minus 8. Okay. We're going to go with that. So what's the domain of f, right? So if you look at the original, we cannot, x cannot be -2 because it makes a 0 in the denominator. So everything except -2. Let me see, type in inequality. They don't want it in interval notation. What's the domain? We want everything except, okay, we can say x is not equal to maybe. I'm going to do x. Use integers or fractions for any, type in inequality. Because this is just like nomenclature. Let me see. X is, what if we do, okay. We're going to say x is less than what we said, was it -2? No, we might get this one wrong because we really need cup cap. Let's see. Type in inequality, use integers or fractions. X is less than -2, and let me do it like this. Say cap, X is greater than -2. So that one I'm not like, I feel like we're not probably typing it right, and I don't have an example to. I know we have the correct answer. It's just, and I thought they would have wanted an interval notation, but they want it set. I don't know if they want to separate it by a comma or an and. X is less than -2 and x is greater than -2. So basically we're saying everything except -2. What's the range of f inverse? So the range of f inverse is the same as the domain of f. So it should be the same thing. Let me see, what's the range? Select the choice. Use integers or fractions for any numbers. I'm going to say y is less than -2, cap y is greater than -2. Okay. Okay, I feel good about that. That's about the best we can do. We might get that one wrong. I'm going to go ahead and submit this. So we got through about 5 questions. Let's hit submit test and see how do we do. Yeah. Let's see, so we did 5. 1, 2. I knew that last one because it's just the notation. You know how they wanted it to look. Let's see. So yeah, and I tried to do that. The not equal to. Okay, that's fine. So we know going forward, right? What we answered is fine. It's saying the same thing. So what we put is correct. It's just different ways of saying the same thing. I didn't think to go a little bit harder looking for that symbol, but yeah, that's it. So not equal. Oh, wait a minute. Range. What is the range? Oh, okay. Now with the second one, I've misread it. I thought they asked for the range of F inverse. They wanted the range of F, right? So, we got that one wrong. Okay, but that essentially brings us to the end of today's lecture. Let me check Zoom one more time. I think the chat is okay for now. So with that, we're going to end the session here. I can't think of anything else, so let me see. So my plan is with the afternoon class. So with you all, if I stop at question 5, then I'll just try to pick up from that point and keep working forward with the 2 p.m. class. Also, if you guys wanted to just come, if you wanted to be live, you're welcome to just join us at that time. You're more than welcome to. But yeah, I just plan to just maybe start with question 6 and keep going forward, and then point them to this video for the first 5 questions. Okay, guys. So if there aren't any burning questions, okay, enjoy the rest of your day. We'll continue exam 1 later today, and then on Friday we'll start exam 2. Okay. Enjoy the rest of your day. Take care. And from one beautiful mind to another, enjoy the rest of your day. Peace.